Okay, so for today's note, we are looking at what is called a difference of squares. Difference of squares, which means that we are looking for us to have two terms that have a subtraction sign in the middle, and we can take the square root of both terms. So we're looking for two terms that have a subtraction sign in the middle, and you can take the square root of both terms. And the square root means just simply like breaking something down into the same number or the same thing times itself. So for example, if I look at a squared minus b squared, a squared is a times a. B squared is b times b. It's important that I have the minus sign in the middle. I have to have a minus in the middle. If it's a plus, we won't be able to factor this way. But if we have two things that we can break down into the same thing times itself, and we have a minus in the middle, then we are going to be able to make factors that look like this. A plus b times a minus b. So essentially we just take one of each of these and put them in each factor, and then one of them should be a plus and one of them should be a minus. So these are going to be the things that we're looking for. Number one, I have a squared minus 4. So a would be a times a. 4 would be 2 times 2. And again, I have to have that minus. So I have a times a minus 2 times 2. And I can break that down into a plus 2 times a minus 2. So number 3, 81 would be 9 times 9. X squared would be x times x. Again, we have that minus. So I can break this down into 9 plus x and 9 minus x. Okay, number 5, we have k squared. That would be k times k. 25 would be 5 times 5. But in this case, we have a plus sign. If we have a plus sign in the middle of our two terms, this means that it can't be factored. So in this case, this polynomial is prime. So I've been forgetting to box my answers. Okay. So now number 7, I have 9b squared, so I have a number and a variable together. The 9 would be 3 times 3, and the b squared would be b times b. So I could split the 9b squared into 3b times 3b. The 100 would be 10 times 10. And we have that minus in the middle. So this is going to give me 3b plus 10 times 3b minus 10. Right, number 16. The 16 we could split into 4 times 4. The a squared we would split into a times a. 121 is 11 times 11. We have the minus sign in the middle. This is going to give me 4a plus 11 times 4a minus 11. And finally, for this page, the 4h squared minus 25g squared. 4 would be 2 times 2, and h squared would be h times h, minus the 25 would be 5 times 5, and the g squared would be g times g. So this is going to give me 2h plus 5g times 2h minus 5g. Okay, moving on to the back side. This one I have more than one variable, number 13. We're still going to do kind of one variable at a time, just as we normally do. So for the x squared, that would be x times x. And for the y squared, that would be y times y. So this is going to be xy times xy. We have the minus sign that we need in the middle, and 1 would be 1 times 1. That is one thing that a lot of people forget about, is that 1 can be broken down into 1 times 1. So don't forget that 1 is a perfect square. It's something that we can write as something times itself. So we have xy times xy minus 1 times 1. That gives me xy plus 1 times xy minus 1. Okay, number 15. 4 would be 2 times 2. C squared would be c times c. We have the minus sign that we need. But then for the next term, I have 5 and d squared. And the d squared, I could write that as d times d. But 5, if I look at the numbers and multiply to 5 on this last sheet at the end, right, the only numbers that multiply to 5 are 1 and 5. So there aren't any numbers like 2 and 2, or 4 and 4, or 3 and 3, where it's the same number times itself that gets me to 5. So up on this problem, the only numbers that multiply to 5 are 1 and 5, which means I can't break 5 down into something times itself. That means that this one is going to be prime. This one can't be factored because we can't break that 5 down into a number times itself, at least not a whole number. Okay, number 17, this one's a little bit trickier because we have k to the power of 6. So it might be a little bit harder to think about what we could break that down into. So let's think about what we have when we have some different exponents. If I have k to the power of 6, or sorry, let's start with k to the power of 2. We said that is k times k. Both of these would have exponents of 1. So let's think about what would happen if I instead had k to the power of 2 times k to the power of 2. Well, when I multiply these variables together, I add their exponents. That's how we get these new exponents. So for this one, k to the power of 2 times k to the power of 2, that would be k to the power of 4. Okay, so let's think about what if I had k to the power of 3 times k to the power of 3. If I add those exponents, that would give me k to the power of 6. Okay, so if I have k to the power of 6, I can write that as k to the power of 3 times k to the power of 3. Alright, if I kept going, just k to the 4th times k to the 4th, that would give me k to the 8th. K to the 5th times k to the 5th would give me k to the 10th. So essentially, as long as I have an even exponent, I'm going to be able to break it down by splitting it in half, essentially. So k to the power of 6 would be k cubed times k cubed. 16 is 4 times 4, and we have the minus sign that we need. So this is going to give me k cubed plus 4 times k cubed minus 4. Okay. So number 19, 121 is 11 times 11. R to the power of 6 would be r to the power of 3 times r to the power of 3. We have the minus sign that we need, and 1 is 1 times 1. So this is going to give me 11r cubed plus 1 times 11r cubed minus 1. Okay, so far all the ones that we've been doing have been problems that haven't had a greatest common factor. But as always, whenever we're working with factoring, we should be seeing if we have anything in common to take out before we solve. So these ones down below are going to be ones that have a greatest common factor that we need to take out before we solve. So, for example, on number 21, the 2n squared minus 72, if I want to break these down into what they might have in common, 2 would be 1 times 2, and then n squared is n times n. 72 would be 1 times 72, not 17, 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, or 8 times 9. So then we look for what they have in common. Looks to me like the biggest thing they have in common is 2. And they don't have an n in common, so it's just going to be 2. I looked at what's left over. I would have 1n squared, or I could put that as just n squared, and then minus 36. So I'd start by taking that 2 out and seeing what's left over. Then what I'm going to do is look at what was left over, what's in the parentheses, and factor that part. So the n squared would be n times n, minus 36 is 6 times 6. So this will give me the factors n plus 6 and n minus 6. Which normally that would mean I'm done there, but we can't forget this 2 that we took out at the beginning. So we'd have 2 and then n plus 6 and n minus 6. Okay, so number 23, we're going to do the same thing. 32 would be 1 times 32, or 2 times 16, or 4 times 8. And then s squared is s times s. 18 is 1 times 18, or 2 times 9. And u squared is u times u. So again, looks like the biggest thing they have in common for these two are going to be 2. So then what's left over is going to be 16s squared minus 9u squared. So then I look at what's left over. The 16s squared would be 4s times 4s, minus the 9u squared would be 3u times 3u. So that gives me 4s plus 3u times 4s minus 3u. And then again, I need to bring down this 2 that I took out at the beginning. Okay, I'm going to skip number 25 and go down to number 27. So same thing, we're going to be breaking these down. 80 would be 1 times 80, 2 times 40, 4 times 20, 5 times 16, or 8 times 10. And then for the n to the power of 4, we would have 4 n's. For 125, we'd have 1 times 125, and 5 times 25, and then n times n. So looking to see what these have in common, looks like they both have a 5 that I could take out. And in addition, they also both have at least 2 n's, and so I could take out n squared as well. Then I look at what's left over. This would be 16n squared, and then minus 25. So I'm bringing this over here, and then I will see if I can factor what's left over. 16n squared would be 4n times 4n minus 25 is 5 times 5. So this gives me 4n plus 5 times 4n minus 5. And then I bring down the 5n squared. Last one that I'm going to do is going to be number 29. So 36p cubed, that would be 1 times 36, 2 times 18, 3 times 12, or 4 times 9. And p cubed would be 3 p's here. 9p would be 1 times 9, or 3 times 3, and then the 1p. So what they have in common, or the biggest thing they have in common, would be 9. And they also both have a p. So I would take out 9p. And then what's left over here is 4p squared minus 1. So looking at what's left over, this 4p squared would be 2p times 2p, minus the 1 is 1 times 1. This gives me 2p plus 1 times 2p minus 1, and then bring down the 9p.